This tutorial reviews the basic properties of exponents. This tutorial is going to be longer than some of them, so you might find it useful to watch it in separate segments. Anyway, the book goes through 9 different properties of exponents, and you need to know about all of them. So that's kind of a lot, so I'm going to try to break it down for you in a way that helps you to use and remember all 9 of them. Okay, so we'll start with 7 of them that you're pretty familiar with already. And of those 7, there's 2 what I would call biggies. And the first biggie is the product property of exponents. And as its name implies, this talks about what happens if you're multiplying, that's what product means, and you have the same base. For example, suppose you have x cubed times x to the 4th, and you want to know what that's equal to. Well, x cubed means multiply 3 x's, x to the 4th means multiply 4 x's, and if you multiply all of that together, you can count them up yourself, you have 3 plus 4, or 7 x's. So that's a property you're familiar with. You've seen that before. That's just a quick review. So, actually, I think there's a faster way to do this. There we go. So a more complicated problem would be one like this. Suppose you had 3y to the 5th times 6y to the 7th. Well, I can multiply 3 times 6, that's 18. And when I multiply y to the 5th by y to the 7th, I get y to the 5 plus 7 is 12. Okay? Hopefully that's review. You've seen that before. So let's erase that example. And here it is for you in symbols. The product property of exponents. A few things to note. This rule works when a, the base, is greater than 0. In other words, when a is positive. Okay, that's the first biggie that you should be familiar with already. The second biggie is the quotient property of exponents. Again, the name implies what it means. This is talking about if you have a quotient, so you're going to be dividing two expressions with the same base. So for example, maybe you have x to the 6th divided by x squared. Well, x to the 6th means you're multiplying 6 x's, 1, 2, 3, 4, 5, 6. And in the denominator, you're multiplying 2 of them. And then, hopefully you know that when you have the same factor on the top and the bottom, you can cancel it out. So I cancel out 2 of the x's from the top, 2 from the bottom. And what's left is 4 x's. So this suggests the following, that you can just subtract the exponents in this case and get x to the 4th. Okay, so let's clean this up and look at a more sophisticated example. So suppose you had the following, 10z to the 12th over 5z to the 4th. Okay, well, 10 divided by 5 is 2. Z to the 12th divided by z to the 4th, same base. Notice I'm not going to divide 12 divided by 4. I'm going to subtract 12 minus 4 and get 8. Okay, again, hopefully that's a review. You've seen that before. So let's clean that up. And then here it is for you in symbols, the quotient property of exponents. Again, this rule is meant to be used when the base a is positive. All right, the next 3 rules I'm going to group together and call them the corollaries. Corollary in math means a theorem or a result that follows closely from another. So based on the quotient and product properties, we have this power of a power property. And this helps us with an expression like this. Here's a power, x to the 5th, and I'm going to raise that to a power. Let's think about what that means. We're cubing x to the 5th. So we're going to multiply x to the 5th by itself 3 times. And then we know from the product property that we can just add these 3 exponents, 5 plus 5 plus 5. And we also know that when you repeatedly add the same number, that's the same as multiplying 5 times 3, or x to the 15th. Again, I hope that's familiar to you. You've seen that sort of thing in previous classes. So let's clean this up and do a more sophisticated example. Suppose you had, where is it? Here it is. 2x cubed you know what, let's save this one. Alright, I'll come back to this in a moment. I'm going to go ahead and give you the symbols for the power of a power. Then I'm going to move on to, sorry about that, I'm going to move on now to the power of a product. So the power of a product helps us when we have a product like 3x and we're raising that to a power. Alright, well let's think about what that means. That means take 3x and multiply it by itself 4 times. Okay, so 3 times 3 times 3 times 3, that's 3 to the 4th. X times x times x times x, that's x to the 4th. So we get 81x to the 4th. Again, hope you're familiar with that as well. You've seen that sort of thing before. Let's clean that up. Now I'm going to give you the more involved example. Suppose you had the following. 2x cubed y to the power of 3. Alright, well we got to cube everything inside. So I got to do 2 cubed, which is 8. I've got to do x cubed cubed, which is x to the 9th, and y has to be cubed as well. So that's y cubed. Okay, so there's a more involved example using a couple of properties at once. And then let's clean that up, give you the symbolic representation, and go on to the power of a quotient. This is the property that will help you with something like this. Suppose you have, let's see, where's my example? Oh, here we go. Suppose you have a quotient, x over y, and you're raising it to a power, 3. Well, what does that mean? That means x over y times x over y times x over y, which is x times x times x, or x cubed, over y, or y cubed. And let's clean up that specific example, and then let's give you the symbolic representation of that. Okay, there you go. Here's another problem that kind of puts all this together at once. Suppose you have 3xy squared over 2x cubed y, and all of that is being squared. Okay, well, everything needs to be squared. So 3 squared is 9, x squared is x squared, y squared squared, well, we multiply the exponents. Then in the denominator, the 2 squared is 4. X cubed squared, well, 3 times 2 is x to the 6th, and y has to be squared as well. Okay, that kind of puts it all together. All right, take a deep breath. There's more.